Welcome to this first video on autonomous systems. Neal Analytics is a cloud, data, and AI Microsoft Gold partner, and we will leverage the expertise we have built with autonomous systems to provide you with a high-level understanding of autonomous systems key components and applications. In this first video, we'll go over what autonomous systems are and where they can be effectively used to solve complex business processes issues. There are some key concepts that are necessary to understand and that are fundamental to the overall autonomous systems approach. This video series is therefore made of 5 videos that tackle all of these topics separately in a snackable short video format. The next videos will tackle the concepts of machine teaching, deep reinforcement learning, and simulations. The final video will review a real-life example that will showcase how all those concepts can be put into application to solve a real-life business process challenge. Please refer to the links in the video description to get access to the different video parts of this series. Let's get started now. First, let's spend some time defining the concept of autonomous systems. To define autonomous systems, we have to not only define what they are, but also what are the business applications they can be used in. So let me first start with this question of where autonomous systems are applicable. The first element that helps identify whether an autonomous system is a relevant option for your business process is to look at whether you need to control and optimize operations for a complex and dynamic process. If your process is controlled in an effective way by a traditional solution such as programmable logic controllers or robots, autonomous systems are probably an overkill. However, if existing control systems are limited, for instance only work in certain conditions, or can't adapt to different input ranges, then adding or replacing them with an autonomous system is probably a good option. In addition, if you need to optimize your process based on competing goals, such as process speed, output quality, throughput, equipment wear and tear, or even production cost, then adding an autonomous system to your existing control system or replacing it by one is probably a viable option. Another key element when it comes to defining whether autonomous systems are appropriate for your needs is to look at the condition in which your system is functioning. If the process inputs values or ranges are changing, if the equipment reacts differently, whether it's new or wear down, or if it's close to failure, then autonomous system-based control solutions can be designed to adapt to those changing conditions. At that stage, you may be wondering, what are the differences between an autonomous system and a traditional automated system? Traditional automated systems manage processes within a predefined set of parameters, such as a given temperature range, set of inputs, or specific output set points. For instance, you could have a PID controller controlling the flow output of a pump. But what happens if the fluid in the pump has different viscosity depending on external factors? What happens when the pump starts to wear out and its yield changes? In these kind of situations, a traditional automation system will require lots of human supervision, adaptation, or might not be able to appropriately deliver the needed process output. If I come back to my example of the pump, and the fluid is an oil that increases a lot in viscosity when the temperature drops, the pump might not be able to reach the desired output pressure when the outside temperature drops. This is where autonomous systems can shine. Autonomous systems can optimize operations by sensing and dynamically responding to a changing physical environment. In the pump example, an autonomous system could dynamically change the pump controller parameters to ensure that, regardless of the outside temperature, the output pressure of the fluid remains at an optimal level. Those two definitions are very broad, so let me give you a few examples of use cases where autonomous systems are particularly interesting. From underground drilling to production to windmill farms to supply chain optimization, all of those use cases combine both complex control systems and the need to adapt to a changing environment. Obviously, those are just a small subset of the application range of autonomous systems, but it should give you a first idea of whether your process is a good target use case for this technology. Now that we have identified where those autonomous systems are the most applicable, let's spend a bit of time explaining what they are and how they function. At the highest level, autonomous systems are one or multiple AI agents, or if you wish, computer programs, that control complex systems. Those agents are built leveraging existing human expertise in your company. Depending on the complexity of the process, one or multiple agents might be deployed to achieve the desired results. And, as you might have probably guessed already, those AI agents leverage the most advanced deep neural networks, or DNN, technologies. Those are the same technologies used in advanced AI solutions, such as speech recognition, machine translation, image recognition, or natural language processing. Autonomous systems are designed using the concept of machine teaching. You can refer to the separate video on machine teaching listed in the comments section of this video to learn more about the concept, but here are the key elements of this approach. First, when designing the system, we will leverage the operators and R&D expertise to define what are the most relevant system variables that need to be taken into account for this solution. For instance, temperature might be very important, but pressure or humidity not so much. Similarly, using the same in-house process experts, we will define what the acceptable output specifications are. Especially for complex systems, the actual specifications, when it comes to what is acceptable or not, can seldom be calculated. Therefore, more often than not, output specifications are best defined through the experience of the people that have been running the process for years. Finally, if there are competing goals when it comes to optimizing the system, this real-life field experience from your experts will be crucial to define the best optimization strategy for the overall system. These also include maybe defining different goals for different agents based on specific conditions. Beside machine teaching, a second key element of autonomous systems is the use of deep reinforcement learning. Deep reinforcement learning is based on the concept of letting the AI train on its own without the need of existing training datasets. Let me double-click 1 minute on this concept because it's a critical one. In traditional AI training, you need to provide a set of training data being the expected output value for each input value. For deep neural networks training, these datasets size requirements can easily run into the millions of individual data points. And in most real-life business situations, those are just not available. Then, during training, the neural network output will be compared with the expected output. The difference between the expected and actual outputs will be used to modify the neural network's parameters. This process will continue and be iterated for each element in the dataset and over multiple eras until the neural network converges to an acceptable quality level. For reference, an era represents one training cycle that has used all the data in the dataset once. With deep reinforcement learning, the agent, i.e. the deep neural network, will use an external simulator and measure the output of this simulator to see whether the action performed generated the expected output or not. Using the difference between what was expected and what happened, the agent will then self-modify its parameters and try again. With this approach, using an appropriate platform, such as the Microsoft Project Bonsai platform, we're able to run millions of training cycles in a matter of minutes. With every cycle, the AI agent learns and gets better until it converges to an acceptable level. An example of a similar approach is when Google showcased how its Go program could learn by playing against itself. In that case, the simulation and the AI agent were two instances of the same AI. This was the most important aspect about the concept of deep reinforcement learning, the ability to self-train. If you want to learn more about deep reinforcement learning, please refer to the dedicated video about the topic.
You can find the link in the comment section of this video. You also saw in the previous slide that because it's not possible to train for millions of cycles on a real-life system, we don't want to destroy it. Training autonomous systems using reinforcement learning requires the use of extremely accurate simulations. I will not get into more details about the process of building these simulations, and I will point you to the video link in the comment section if you want to learn more. The final step, once the autonomous system has been built, is to deploy it. How you do this falls into a continuum of options that can vary depending on the implementation strategy you decide to adopt. On one hand, you can decide to go totally automatic. In that case, the autonomous system, the AI agent, will directly control the process. Operators will supervise its operation and ensure that everything goes according to plan. On the other side of the scale, customers can also decide to let their system work the way it functions now, but use the AI agent as an advanced advisor for the operator. The autonomous system will then offer options that the operator can decide to implement or not, based on, for instance, additional externalities that needs to be taken into account. This concludes this introductory video on autonomous systems, and I hope you found it useful. We would love if you could leave us comments, like the video, share it, and subscribe to our channel. Finally, please check out the other videos of this 5-part series to learn more about the different components we've mentioned, as well as to see an example of where Neal Analytics deployed an autonomous systems for a large food manufacturer.